Okay, what we're going to do in this vodcast is take a quick look at pressure. Now, pressure is typically something that we would talk about when we talk about gases, and we will talk about it in lots of detail when we talk about gases. But we do have to talk about air pressure because it's related to phase changes. So what we're going to do is look at units and how to convert between units of pressure and talk about what pressure is. Okay, mathematically speaking, pressure is simply force over area. So if you were calculating pressure, that's how you would calculate it. We won't deal too much with the calculations of pressure. In fact, you probably won't see any calculations about it. But let's just talk about what it means briefly. Let's say, for instance, I had one of my students lay down on the floor, and I gave them a choice whether or not as I stand on their chest, I could stand on a book on their chest, or I could have a pencil, and then I would stand on the pencil. So I'm going to give them a choice. I'm going to place a book on their chest and stand on it, or I'm going to place a pencil on their chest and stand on it. Obviously, you would choose the book. The idea is you're spreading that force over a larger area. So you've got the same amount of force, in other words, it's my mass, but since you're spreading it over a larger area, you're making that denominator larger, which would make the value smaller. So there's less pressure when you exert the pressure over a larger area. Obviously, if you stood on a pencil, well, we don't even need to talk about how that would finish. Same idea as if you were walking over thin ice and you started to hear it crack. What's the first thing the first thing you should do is lay down flat on the ice. That way there's less pressure on the ice. You're exerting the same amount of force over a larger area. Okay, let's talk about what air pressure is then. So pressure is the force over a certain area, so air pressure is nothing more than, let's say you're standing here, it's nothing more than the column of air above your head. Assume that air is basically made up of nitrogen and oxygen. Those molecules, as you know, have mass. So all of those molecules above your head have mass that are pushing down, so it's creating a certain amount of force over a certain amount of area. And that's what we refer to as air pressure. So if you were to climb up a mountain and you were to stand up on the top of a mountain, we know that air pressure is less, and it's less because that column of air is less than the column of air if you were standing on the ground. So when we talk about air pressure, it's the amount of force pressing down on whatever the object happens to be. Let's talk about units of pressure right now. We talked about SI units back at the beginning of this course, and the SI unit for pressure is a Newton per meter squared. Well, you really shouldn't even call it an SI unit. What it is it's a derived unit from the SI units, Newton and meters. Anyway, the unit for pressure is a Pascal. In fact, usually what we'll use is kilopascals. And remember, kilos stands for 1,000, so 101.3 kilopascals would be 101,000 pascals. One of the units that you'll often see us use is 1 atmosphere, abbreviated ATM. And atmospheres is that 1 atmosphere is the amount of pressure exerted by that column of air that we were talking about. So we say 1 atmosphere is equal to 101,000 pascals or 101.3 kilopascals. 1 atmosphere is also equal to 760 millimeters of mercury, and we'll talk about where that comes from when we talk about the gas laws, and it's also equal to 760 torrs. So you will see these units used: atmospheres, kilopascals, sometimes pascals, millimeters of mercury, and torrs. So what you'll often have to do is convert between units. So let's say the pressure of a gas is measured at 2.5 atmospheres, and we want to represent this in torrs and pascals. Well, you simply do the dimensional analysis that you've grown used to. 2.5 atmospheres, you want to cancel atmospheres, so 1 atmosphere is equivalent to 760 torrs. Do the math, and you get your answer with the unit torrs being left over. If you were converting to pascals, then you would say 1 atmosphere, 101,325 pascals. Atmospheres cancels, the unit, do the math, and you get your answer. So you're doing basic conversions that you should be quite proficient at this point. Let's just do a couple of quick conversions. Let's convert 600 millimeters of mercury into atmospheres. So 600 millimeters of mercury. How many millimeters of mercury are in an atmosphere? 760. 1 atmosphere. Do the math. 600 divided by 760 gives us 0.79 atmospheres. Millimeters of mercury cancels. Our unit is left over. 190 kilopascals, if we convert that to atmospheres, 101.3 kilopascals per atmosphere. Do the math, 190 divided by 101.3, and you get 1.9 atmospheres. The next one, you've got 2.3 atmospheres. 1 atmosphere, 760 millimeters of mercury. Do the math, 2.3 times 760, 1748 millimeters of mercury. And the last one, 1.5 atmospheres. 1 atmosphere, 101.3 kilopascals. Do the math, and you get 151.95 kilopascals. So hopefully those conversions are rather easy for you. The point of this podcast is to understand what pressure is, being the force over a certain area, and then the units of pressure. And we have units of atmospheres, pascals, kilopascals, millimeters of mercury, and torrs. And again, we'll discuss where that one comes from when we talk about the gas laws.